Uh, Let me take a simple example that I want to multiplex two channels. Let it be S1 of t. Okay. This is my first channel. This is my first channel, and let it be, sorry, S1 of t. S2 of t, I have my second channel. So these two channels, these two signals, not channels. I have S1 of t and S2 of t. These two signals are to be transmitted on the same channel using PAM. So my S1 of t is a PAM signal, let us suppose. S2 of t is another PAM signal. So therefore, what I do is I use a switch here, which can be moved from position 1 to 2 and 2 to 1. Then I have a transmitter. So in between, this is my free space array, what we call it a channel. At the end, I can have a receiver. Again here, I have a switch to move from 1 to 2. So this is how we demultiplex at the receiver S1 and S2. So this is my channel, right? Channel between what is between transmitter and receiver is my channel. So if I take a simple example of TDM, this is how it will look like a two-channel time division multiplexing concept. Now, let us see how my S1 of t looks like and how S2 of t looks like. I'll take some other color. Okay. Yeah. So here, assume this is my M of t. Let us suppose for S1 of t. And I'm using a flat top sampled signal. Let us suppose flat top sampled PAM. So at regular intervals, my samples would be. So here I have a pulse like this. So because the amplitude is more, I can have. And then here also. What about here? Here also. Sorry. This is my PAM signal of S1 of t. Fine. Now I'll take the second example. I'll take another what we call it as S2 of t. Let it be my S2 of t is assume my S2 of t is something like this. This is my S1 of t, and this is the S1 PAM. And this is my S2 of t. Now, S2 of t PAM would be during the same, not same sample time. Keep remember, I'll take some other time. So here I got a pulse with large amplitude, thereby a pulse with small amplitude, then again small, of course. Now the amplitude of the pulse increases. This is my flat top sampled uh, S2 of t, S2 PAM. Now the question here is, if you observe carefully, I said there is a switch. There is a switch S which continuously switches from 1 to 2 and 2 to 1 over a certain period of time. So I choose the switching action of this particular switch. I fix the time in such a way that it will take the first sample of, it will take the first sample here, then it will move to the position 2, then it will take the second sample as S2 of t. So both put together, if I draw, both put together, if I draw, so here I got my S2 of t. This is your S2 of t. And see this one. So when the switch position is at position 1, then I got the signal like this. And then it is switched to position 2. Now the sample of second signal has been taken and dropped over the channel. This is my again S1. When the switch is moved to position 1, again the switch is moved to position 2. You are following? Did you get my point?
Yes, sir.
So it is purely dependent on the switching action, that how good the time synchronization is, how good we keep the time synchronized from position 1 to 2 and 2 to 1. Now, whatever the signal I have drawn is now in the channel, the last one. This signal is transmitted over the channel. And this is what we call it as time division multiplexed signal. So here, if you observe carefully, these are the samples of your S1. And these are the samples of your S2. This is the fundamental concept of time division multiplexing, because this once the first pulse is over for S1 of t, till the next pulse of S1 of t, the time is wasted. So during that interval, I am transmitting my signal S2 of t over the same channel, such that I can utilize the channel to the maximum capacity. Maximum capacity. The channel can be utilized. Now the question is, how many such channels, or how many such, sorry, not channel, how many such signals can be multiplexed over the same channel? It depends on, the time available from one sample to another sample of same signal. If in between I have a good enough amount of time, I can introduce, or I can multiplex, say 4 signals, 4 PAM signals, or 10 PAM signals, even 100 PAM signals also. So it depends on the sample time. So number of uh, signals to be multiplexed depends on sample time interval Ts. So as an example, I have taken a simple uh, multiplexing of 2 signals. So at a big picture, the generalized block diagram of a TDM will look like this. So I have several signals. Let it be M1 of t, M2 of t, M3 of t, M4 of t, so 8 signals I want to multiplex. So pass it through a PAM modulator. So 8 signals M of t, we pass it through a PAM modulator. Now I got 8 PAM signals. So these 8 PAM signals can be, uh, multiplexed, something like this. Let it be. So here I have a switch, and that switch is operated with a commutator. If you observe carefully, from signal 1 to till 8, one complete cycle will take TS time. Keep remember. So now this is passed through the channel. This signal, the multiplexed signal, is passed through the channel because we have only one channel. Now what happens at the receiver? At the receiver, I have again the same. Instead of modulators, I have demodulators. So I have a switch here. So here, two, three. So I have a demodulator here, PM demodulator, that is the sample and hold circuit. So demod, similarly, all the demodulators. Now the question here is, the care should be properly taken both at the transmitter and receiver end in such a way that the operation of this switch on both sides should be synchronized properly. The operation of the switch on both sides should be synchronized properly. So that is what we call it as time synchronization. Time synchronization on both sides. Because how much amount of time you spend for M1, how much amount of time you spend for M2, so on and so forth, the same amount of time should be spent at the receiver end also. Otherwise, my M1 will go to second path, may take the second path. It should not happen. So that proper care should be taken. The time synchronization with respect to both transmitter end as well as at the receiver end. Clear?
Yes, sir.
Okay. So now, having seen this, let us move to the very next important topic called pulse width modulation. Before going to pulse width modulation, let me explain what is the advantage of TDM. Can you tell me what is the advantage of TDM?
Bandwidth is more.
Perfect. You can have the full bandwidth, infinite bandwidth you can transmit. Then what is the disadvantage?
Synchronization is important.
Delay.
Delay. Both are correct. So assume I have 100 signals to be transmitted. So the first turn signal 1 is transmitted, and the signal 1 for each signal there is a time allocation of 1 millisecond, let us suppose. Again, the first person has to send the same his own signal. He has to wait for 100 milliseconds. Okay. Assume if the number of signals to be transmitted is 10,000. So the delay comes into picture, right? Delay comes into picture. So it should not happen. So that is the disadvantage of TDM. The advantage is you can send any amount of bandwidth. That is the advantage.